So instead of reduction, let me take oxidation potential only to make things easy. If I am taking oxidation potential, I'll add a negative sign in both cases. Correct? So for oxidation to happen, the first reaction, for chlorine to get oxidized to chlorine gas, I need 1.36 volt of energy. Correct? For water to get oxidized to oxygen gas, I need 1.23 volt of energy. So to oxidize water, I need 1.23 volt of energy, and to oxidize chlorine to chlorine gas, I need 1.36 volt of energy. Looks like water will win, but here is the catch. We have over potential coming here. I told you, for water, to oxidize water, it takes more than 1.8 volt minimum. So this 1.23 is actually 1.8 volt because of over potential. Now let's compare. Now if you compare, to oxidize water you need 1.8 volt. To oxidize chlorine you need 1.36 volt. Which will win? Obviously chlorine. So chlorine gas will come here. Little tricky question, please understand. See, at cathode it was pretty easy, right? I had this for sodium reduction 2.7 volt, water reduction 0.8 volt. Obviously water reduction will win. At anode there was the issue. At anode we have over potential also there. Please note, over potential is generally the anode. Over potential of water we have seen is 1.8 volt, right? Without applying over potential, it looks like the competition between chlorine and water, water will win to get oxidized. But the moment you apply over potential concept, you will see that water needs 1.8 volt to oxidize, chlorine needs only 1.36 volt to oxidize. Thus, chlorine will win and chlorine will get oxidized to chlorine gas. Let's see with the sulfuric acid. It's aqueous sulfuric acid. It is not mentioned, it is dilute or concentrated. It is not mentioned, so we'll see for the both scenarios. Correct? Sulfuric acid, if you see, I have H2SO4 that will break into H plus and SO4 2 minus ions. Correct? So this is my anode, this is my cathode. Cathode will have a lot of electrons, and at cathode will have reduction happening. So I have cathode and I have anode. First let's see cathode. So cathode I have reduction. So what are the potential candidate for reduction? So I have H plus can reduce. So H plus is one candidate for reduction and water is one candidate for reduction. Both are same actually, right? I'm saying H plus is getting reduced or water, both are same. In both cases you'll get hydrogen gas, right? H plus will give you hydrogen gas, and H2O also, if you see reduce this H2O, if you reduce this, it will take electrons. This will take one electron, and this will become hydrogen gas and 2OH minus. So that means in both cases the only possibility of gas coming out from here is hydrogen gas. Done, no issue. Let's talk about anode. In anode, they are candidate for oxidation is either SO4 2 minus ion or I have water. Let's see the reaction. I'll see the oxidation reaction. Reaction at anode, both possibility, we'll see. Let's see for water. I have the water, I'll oxidize it, it will become oxygen and it will give me some H plus and 4 electrons, it will be 2 to balance, yeah. And for this, the E will be 1.23 volt. And let's, another case is SO4 2 minus. It becomes S2O8 2 minus and gives 2 electron, and this E is 1.96 volt. Now you see there is a almost tie, but now there is a anode and there is water, oxidation of water. It will not be 1.23 volt, it will be 1.8 volt. Correct? Please note, I am not talking about the reduction potential, I am talking about the oxidation potential here. I wrote oxidation potential directly here. Sorry, this is reduction potential only. Right? So if you find the oxidation potential here, this becomes minus 1.23 volt, and this is oxidation, you write, this becomes minus 1.96 volt. But actually, because of over potential, This is the value. Now if you see 1.8 volt, 1.96 volt is almost a tie, right? Now if you talk about a dilute solution, then you have more of water. Since there are more water, it is like there is a state and they are almost same level of people, right? They are people of category A or people of category B. Who will win? If they are of same level, now the number of people will win, right? The strength will matter. So if they are, let's suppose, out of 100, if they are 90 of A and 10 of B, obviously A will win in the fight. Assuming A and B both are of same capability, right? If I have 90 of B and 10 of A, obviously B will win in the fight. If there's a town and in town there are 100 people and they're fighting, and there are two type of people, A and B only. So here also, if I am taking a dilute solution, my water concentration is more. What I'm seeing is the energy required to oxidize water or SO4 minus is almost same. Thus, if I have a dilute solution, then there will be more water molecule. Then in that case, reaction 1 will take precedence and you will get oxygen here. If it's a concentrated solution, then you have more SO4 minus ion solution because H2SO4 is a strong acid. So in that case, these people will win, assuming this is A and this is B, right? They will win, and they will win. In that case, you get S2O8 minus ions. Hope you understand. There's a tie here between sulfur SO4 2 minus and the water oxidation. So again, it all depends on the concentration of sulfuric acid. We have to predict the product of the electrolysis in each of the following case. The first is aqueous CuCl2 in platinum electrode. So I have, in both cases, I have CuCl2 here. First case I have platinum electrode. Second case I have copper electrode. Let's see the case one. I have platinum electrode, right? So CuCl2, that means I have Cu2 plus ions and Cl minus ion. Correct? This doubt in this? No doubt. So this is my anode and this is my cathode. Here will have negative charge, so we will have more electrons here. Here will have positive charge. Correct? So first let's do for cathode, where we have reduction happening. So reduction, the possible option is either copper Cu2 plus ions from the solution can get reduced, or water itself can get reduced. Like only two options I have. If you talk about the copper ions, if I have write the equation Cu2 plus takes 2 electron becomes copper. This is 0.337 volt. In fact, this is a spontaneous reaction on its own. Is it? Copper reduced on its own to become copper. Copper ion reduced on its own to become copper. This is a spontaneous reaction. For water to get reduced, the reaction we'll write as H2O takes 2 electron becomes hydrogen OH minus, and here E is minus 0.83 volt. That means water needs energy to get reduced, but copper plus ion itself will get reduced. It doesn't even need energy, right? So by default this will get priority, correct? Because it has positive value, it has a negative value. So copper ion will reduce to become copper, it will give energy. Water will reduce to, but it will take energy, right? This is a non-spontaneous reaction. This is a spontaneous reaction. There is no questions. By default, this reaction will take precedence. So at cathode, the copper deposit will happen. This is for sure. Now let's see the anode. Anode, something will get oxidized. So I have option between Cl minus ions, and I have option between water. Either water can get oxidized or chlorine cannot get oxidized. So let's see this reaction. Chlorine takes 2 electron to becomes 2 Cl minus. I wrote the reduction reaction actually in both cases, right? Let me write the oxidation reaction. Chlorine will take 2 electron to becomes 2 chlorine, and water oxidation, water will become oxygen and it will give 4H plus and 4 electron. Correct? Sorry, it will give 2 fluorine. Yeah. Now for this, if you if you see the reduction potential, that is nothing but 1.359. That is reduction potential. And for this, it is 1.23 volt. It is minus. So since this is a reduction potential, this is also a reduction potential. Actually, I can write the oxidation potential for both. This is plus 1.23. Both are plus actually, right? This is the reduction potential for chlorine. This is the reduction potential for water. If I write the oxidation potential, both will get a negative charge. That means to oxidize the chlorine, I need 1.35 gram of 1.35 volt, and to oxidize water, I need 1.23 volt. Correct? But again here, over potential will come into picture. This is actually not 1.23 volt. Practically, it is plus 1.8 volt. That means to oxidize water, I need 1.8 volt, and to oxidize chlorine, I need 1.35 volt. Correct? That's what it means. So I need more energy to oxidize water, less energy to oxidize chlorine. So chlorine will get oxidized and it will become chlorine gas. So here you will get chlorine gas as out. Correct? Here copper will get deposited. Cu2 plus will become copper, and here chlorine gas will come out because there will be tough competition between chlorine gas and water molecule. Water molecule will need 1.8 volt to get oxidized, and chlorine gas will need only 1.35 volt to get oxidized. Thus, chlorine gas will win. Let's take the second scenario where we have copper with copper electrode. This is my copper. Again, we have copper CuCl2, so we have copper plus 2 ions, and we have Cl minus ion. Again, here is my anode. This is my cathode. Right? First, I'll write for cathode by convention. So cathode will have reduction. So what all possibility you have for reduction? Cu2 plus ions and water. So if you see this reaction, Cu2 plus ion will take 2 electrons and will reduce to copper, and the electron volt is 0.7, sorry, it is 0.337. That means this much energy is liberated. It's a spontaneous reaction. You don't even need energy. This much energy is liberated. If you talk about water oxidation, reduction. If you talk about reduction of water, it will take 2 electrons, it will become hydrogen gas and OH minus. E is minus 0.83 volt. That means in this case, energy is required. Energy is required to reduce water. So the first reaction will take precedence. Why? Because it is a spontaneous reaction. You don't even need energy. Second reaction, water, energy is required to reduce water. So here copper deposit will happen. Fair enough, done. Now let's talk about anode. Trick part. Anode, I have some oxidation will happen. So here for oxidation, I have one option of Cl minus gas. One option is my water. And the third option I have is my copper itself. Copper may get oxidized. Correct? So let me write the reaction for all. Cl2 gas. This will become Cu2 plus. In fact, this will give electron actually. Plus 2 electron. And water will also get oxidized. It will give water, oxygen, plus 4H plus 4. If you write the value, this is nothing but plus 1.23 volt. I am writing reduction potential for all. This is also plus 0.337 reduction potential. And this chlorine Cl minus becomes Cl2, that is 1.379. In all this case, I am having oxidation, but I wrote reduction potential. What does this imply? This implies that 0.337 volt of electricity is required to oxidize copper. 1.23 volt, and actually if you add oxidation over potential, this becomes 1.8 volt. 1.8 volt current is required to oxidize water. 1.3 volt current is required to oxidize chlorine, but only 0.337 volt current is required to oxidize copper. Thus, here copper will get oxidized to copper plus. Nothing will get deposited. Right? So copper will get oxidized to copper plus. It will go into solution, and here copper plus will become copper, and thus electroplating will take place. Understand why chlorine or water will not get oxidized here? Why copper will get oxidized here? Because with the reduction values, it's pretty easy to see that 0.337 volt of current is required to oxidize copper, 1.8 volt is required to oxidize water, and 1.39 volt is required